We're asked to find the exact value of the expression in terms of x, assume x is greater than 0. We are given cosine of 2 times inverse tangent of 3x. Inverse tangent of 3x is equal to an angle theta that has a tangent function value equal to the input into the inverse tangent function. And the angle theta must be in the open interval from negative 90 degrees to positive 90 degrees. So in our case, inverse tangent of 3x is equal to some angle theta where the tangent function value is equal to 3x. Let's write 3x in the form of a fraction or a ratio with the denominator of 1. So the tangent function value of theta is equal to 3x divided by 1, which means we can write the original expression as cosine of, don't forget about the coefficient of 2, which gives us cosine of 2 theta. And now for the next step, let's sketch the angle theta on the coordinate plane and then sketch the reference triangle. And because we are given that x is greater than 0, we know the angle theta must be in the first quadrant. So let's say this is the angle theta. And now let's sketch the reference triangle. We know tangent theta is equal to the ratio of the opposite side to the adjacent side, which means for our reference triangle, we can label the opposite side 3x and the adjacent side 1. So we have 3x on the opposite side and 1 for the adjacent side. And now let's determine the hypotenuse. Let's label it c. We can determine c using the Pythagorean theorem, which is c squared is equal to a squared plus b squared, where c is a hypotenuse and a and b are the lengths of the legs, which gives us c squared is equal to, let's let a equal 1, which gives us the square of 1, plus let's let b equal 3x, giving us the square of 3x. Simplifying, we have c squared is equal to 1 plus the square of 3x is 9x squared. And now we know the hypotenuse is always positive, so now we'll take the principal square root of both sides of the equation, which gives us c is equal to the square root of the quantity 1 plus 9x squared. Let's go ahead and label the hypotenuse. And now let's evaluate the expression cosine 2 theta. To do this, we will use a double angle identity for cosine. And notice how we have 3 to choose from. It doesn't matter which one we use. Let's go ahead and just use the first one. And therefore, cosine 2 theta is equal to cosine squared theta minus sine squared theta. And now we can determine the cosine and sine function values of theta using the reference triangle. Cosine theta is equal to the ratio of the adjacent side to the hypotenuse, which gives us 1 divided by the square root of the quantity 1 plus 9x squared. But we have cosine squared theta, so we square this fraction, minus sine theta is equal to the ratio of the opposite side to the hypotenuse, which gives us 3x divided by the square root of the quantity 1 plus 9x squared. And again, this is also squared. And now to square the fractions, we square the numerator and we square the denominator. So for the first fraction, 1 squared is equal to 1. When we square the denominator, the squaring undoes the square root. The square of the square root of the quantity 1 plus 9x squared is just 1 plus 9x squared. And then we have minus the square of 3x is equal to 9x squared. And again, squaring the denominator undoes the square root, giving us the quantity 1 plus 9x squared. And now we're almost there. Notice how we do have a common denominator, and therefore we subtract by keeping the denominator the same, and then we subtract the numerators. So we have cosine 2 theta is equal to, in the numerator we have 1 minus 9x squared. In the denominator we have 1 plus 9x squared. Notice how we do have a difference of squares in the numerator, so the numerator does factor, but since the denominator is a sum of squares, it does not factor, and therefore the expression does not simplify, and we are done. And we do get the same result using any of the 3 double angle identities for cosine. I hope you found this helpful.